Hi, Sean here from the Vintage Model Radio Museum. As a follow-on from the earlier video showing a modern 2.4 gig version of this, I thought it'd be interesting to actually show some early pulse proportional sets in action. On the left, tremendously popular, the ACE system. Testors in the middle. Testors, I believe, used to distribute the Wenmac motors and some of the small plastic control line kits, and no doubt other items. The surprising one is actually the blue one. This is by Mattel, the toy manufacturer. This was made in Japan and it's a high quality product. Don't be fooled by the look of the stick, it's actually only rudder control. I've no idea why they made it look like that. Okay, what I propose to do is set up a couple of these and show them in operation. Okay, the first set to be demonstrated is called Simpl Simul. It was by Tester RC Corporation, which was part of Testors. I'll just show you a close-up of the actual actuator. This is an Adams. It was a mid-range one, fairly powerful. You can see the construction is very simple. It consists of a coil with a permanent magnet on the disc, and essentially what happens is the current passing through the coil is changed, so the polarity changes and it flicks it one way or the other. Receiver is a C&S Developments Super Generative one, slightly off tune at the moment, that's why I've got to wrap the aerial around the transmitter aerial to make it work. And as you can see, it runs off 3-cell battery pack, fairly small for the time, lightweight, and obviously the advantage is that you didn't need any rubber as with an escapement, so it allowed some different configurations of aircraft to be made. So here we go, power on, and you can see it flapping away there. Now then again, just pull in a little bit. As you can see, if I push this stick to the left, it biases the actuator to the left. Right rudder biases it over to the right, and in the centre it's flapping both ways. The clicking you can hear is actually mechanical stops. Very simple, very effective. It did have limited output power. There you go again, and as you can see, as I explained on the previous video, what happens is the flight path that the aircraft takes is actually an average of the two extremes of the flapping. So there we go, full right, centre, full left. A little bit harder to see, but it's the average of all the points in between. The next one I'd like to show is actually the Mattel set. The next system is the Mattel one. As I said previously, surprising, it's very robustly made. Quite heavy though, for some reason they chose to use subsea batteries. The actuator is a vanilla type one, not quite the quality of the Adams, but similar size, and it does behave very well. An unusual feature of the receiver that you can see is this piano wire aerial. Thoughtfully they did put a little loop on so you wouldn't blind people, and it does run off just 2 cells, this one. So again, much of the same, as you can see, over to the right. The pulse range on this one's a little bit different, but there you can see. Now these actuators would have been mounted either that way in the plane, as in the case of this David Boddington example that I showed, and then you fasten that to a torque rod which rocks the rudder. Another option, you could actually mount it that way and have a string going to the rudder, and then the other side of the rudder would have a small rubber band on to provide some centering force. This actuator is driven both ways electronically. It's got 3 connections to it. Just zoom in and have a look there. There again you can see the permanent magnet at the back and the coil, and the electronics which is built into the receiver is providing the switching action.